Hello, my name is Cody Bowerman, and I'm going to talk about how the conservation of energy was demonstrated in my experiment. So, let's start from the beginning. So, as you saw in the clip, you saw that I had that clay ball that I was attempting to try to hit that little switch with, and I finally did, which caused Thomas to fly down the tracks and then collide with a block. And then that block falls down and hits the slinky. And so this is where I'm going to show you a good example of how the conservation of energy was demonstrated in my experiment. So you have the slinky sitting here on top of the stairs, and the slinky, when it's just sitting there, it's at equilibrium because it's not moving, it's not doing anything, and he's just sitting there just waiting for something to happen to him because he has potential energy. Since he's been elevated, he's been raised up, and he has a mass, so he has some potential energy waiting to get converted into kinetic energy. So whenever that block comes and whacks him on the side of the head, that causes him to start to move down the stairs, which also converts his potential energy into kinetic energy. And then it goes down again, so then his potential gets converted into kinetic until it finally reaches the bottom, and all of his energy gets dispersed into sound, into the impact with the table, and then finally impact with another wooden block, which starts the chain reaction for the domino effect, which then takes the picture, which then, well, it pushes the pencil to take the picture, but you know, you get the picture. So conservation of energy was conserved. There was no energy that was created, and none of the energy was destroyed. So from the initial impact of the little wrecking ball, clay ball, to the very end, to when it hits the iPad to take the picture, the energy was conserved. And just like in the slinky, it was kind of like a little miniature example of that, because the slinky's sitting here at the top, and he has all this potential energy, and then he gets knocked, and then that energy is in motion. He's no longer at equilibrium, and then he gets to the bottom, and he's back at rest, and he's back at equilibrium. And so that's how conservation of energy was conserved in my experiment.